Hello everyone, welcome back to my channel AWS DevOps Niche 11. So in this video, we are going to talk about a niche topic, how to install Prometheus and Grafana using Helm. So we are going to use the Kubernetes Helm charts to install Prometheus and Grafana. So let's see how to do that. Before that, I'm going to give you some points about what do you mean by a Helm repository, etc. And then we can move ahead into the lab. So what do you mean by Helm? Helm is actually a package manager for Kubernetes. Just like we have the package managers for our Linux operating systems. So we have yum for the Red Hat Linux. Similarly, we have apt for the Ubuntu Linux, etc. Right? So in the similar way, Helm is a package manager for Kubernetes. So if at all you want to install any packages on the Kubernetes cluster, we can use the Helm charts. To package YAML files and distribute them in public and private repositories. So whatever packages are available in the public and the private repositories, which are basically bundled for the applications, so we can download it from the Helm repository. So there is an example here. If I just go to this link, okay, so this is a Helm repository where we can see all the needed components that is needed to install the packages. So basically you can say that the Helm repository is a combination of all the needed packages in order to install the necessary applications. So in our case, we are going to install Prometheus and Grafana. So whatever YAML files, the manifest files are needed in order to spin up those applications, everything is bundled and packaged along with other dependent files within this Helm repository. So we all know about the GitHub, right? GitHub, which is the central repository for the source code. In the similar way, Helm repository is a central repository for the packages that you want to install on the Kubernetes cluster. So if I go back to my slide, so what is a Helm chart? Helm chart is a bundle of YAML files. So it can be a config.yaml file or any YAML file that would be needed, or I would say manifest files that would be needed to create and operate your Kubernetes cluster. So we can also create our own Helm charts with Helm. So Helm is having its default Helm repository. We can also customize it and we can create our own Helm charts. And we can push them to the Helm repository, download and use the existing ones as well. And that is what we are going to do. Whatever is the Helm chart that is already available for Prometheus and Grafana, we are going to install that. Helm charts can be shared via public and private registries. Just like our GitHub repository. So there is a Helm repository, which is again a public repository. And the Helm charts available on the repository can be leveraged based on the applications that we want to install on the Kubernetes cluster. Now, what are all the features of a Helm chart? Helm chart can act as a templating engine, and we can redeploy the same applications across different environments. For example, now we have a Helm chart for Prometheus. So if at all we want to deploy that Prometheus monitoring tool across the dev, staging, and prod environment, we can leverage the same Helm chart. That's the reason it's said that it can act as a templating engine. So there are some important links about the Helm. So we have the link for Helm Hub, and there is a Helm charts GitHub project. There is a link for it, and there is a link which has the steps to install Helm and Helm version 3 release note. So I'm going to anyway put these links in the description of this video, so you can take a look at these links. Okay, so now let us go into the lab on how to install this Prometheus and Grafana applications using the Helm chart. But before that, what is the prerequisite? You need to have the Kubernetes cluster spinned up ready. So that is a prerequisite. And I'm not going to show that in this video, because if you have watched my previous video, I have explained about various ways how you can spin up the Kubernetes cluster. So I have a video on spinning above the Kubernetes using kops. Then I also shown how to spin up the Kubernetes using kubeadm. And my last video was on spinning Kubernetes using the EKS, Elastic Kubernetes Service. So I request all of you to first watch that video. You can just click at the top of the screen. You can watch this video on how to spin up the cluster using EKS. Get your cluster ready, and post that you can try the steps to install Prometheus and Grafana using the Helm charts. So the point I'm going to start with here is directly I'm going to start with the installation of the Helm and then installing Prometheus and Grafana using Helm. So the prerequisite is please have your cluster created using the EKS or maybe any other means, but EKS video is the last video that I had created a couple of weeks before. You can take a look at that video and you can get a cluster created. Now let's get into the lab. So now what are all the steps to install Helm? We'll anyway go through this. But before that, I want to log into my EKS Bootstrap server. So this is a EKS Bootstrap server on which I actually executed various commands to create a cluster, to create a Kubernetes cluster using the CloudFormation stack. So now I have a Kubernetes cluster. It is having a couple of nodes also created. So I'm going to just verify the cluster. So let me give the command EKSCTL get cluster. Okay, I think I'll have to give the region -- region, and my cluster is in North Virginia region, which is US-East-1. You can see here, this is the cluster that I created using EKS. The cluster name is test-cluster, which is in the North Virginia region, US-East-1, right? So now if I give the command kubectl get nodes, so it is going to list me all the nodes, whatever is part of the cluster. So there are 2 nodes that is part of the cluster, and these are the ones what we see in the EC2 console here. So this is one node, this is the second node. So now I have my cluster ready. Now what I need to do is the next step, I need to go ahead and install Helm. So we will see that step by step how to install Helm. Okay, so there is a link from which you can actually get the instructions to install Helm. Anyway, I'll put this link also in the description. So if I go to this link, you can see the steps here. Okay, so whatever version of Helm that you want to download, you can click this desired version and download the Helm version. Then you need to unpack it with the tar command. And then you have some remaining steps to be done. So we will follow the instructions one by one. So the first step is I'm going to download the Helm package, that is version 3.10 is what I'm going to use. And I'm going to download it from the central repository. So my first command will be wget and this particular repository link where my Helm version 3.10 package is available. So let me execute this command. Okay, now it has downloaded the Helm package. Now I need to extract the package. So I'm going to give the command -xvzf, and this is my compressed package for Helm. We can see that it has compressed the package. Now let me go into the directory Linux-AMD64. So here you can see there is a Helm binary, and this is a command I'm going to use in order to add the repository for Prometheus and Grafana into my local system. Basically, I'm updating what is the remote repository for Helm. Okay, just like how we do for GitHub. So in the Git machine, we'll update what is the GitHub repository where the code has to be uploaded. So in the similar way, in my system running Helm, I'm adding the remote Helm repository from where the packages can be downloaded. So this is a command. Okay, so Helm repo add Prometheus-community, that is the Helm chart name, and the link for that repository. Okay, so this is a format. So what this will do is we are actually telling our Helm on the local machine that this is our remote repository from where it has to download the packages. So here it says the Prometheus-community is already existing, so it is skipping that configuration. But if at all you are creating it new, it is going to download it. Okay, now I will give the command Helm repo update. Right, so it is saying successfully got an update from this particular Helm chart. Update is complete. Okay, now we are going to do an install. So Helm install Prometheus, that is the chart name, and this is the files which is available in the repository. Okay, so Helm install, here the Prometheus is basically your release name. This one here, this is your release name. Okay, I will just say it's a release name. So Helm install release name, then you reference the package name, whatever is available in the Helm repository. So if I actually go to this particular link, this GitHub repository, you can see here it is Prometheus-community/Helm charts. So here what we are giving, so we are saying Prometheus-community, that Helm charts is something default it will take, but what is the exact the package name under the Helm charts? Cube-Prometheus-stack. So this is the stack that we are going to use and install our Prometheus and Grafana. Okay, so the format is Helm install release name, and then the Helm repository name / the stack name which is available in the Helm repository for us to install the packages. So let me press enter. So it takes a little bit of time in order to configure, all the needed components for the Prometheus and the Grafana application. Okay, now you can see here, it is saying the status has been deployed. Basically, all the Kubernetes components, including pods, services, replica sets, custom resource definitions, everything would have got created for these two applications, Prometheus and Grafana. And you saw how easy it was to just have them set up from the Helm repository. You can see here, the status is deployed here. And we can also just validate with this command, kubectl namespace default get pods -1 release is equal to Prometheus. You can see here, these are all the various pods that it is running for the release Prometheus. So we have 4 pods running for the release Prometheus. Okay, so now let's try to execute some commands and try to get some information. One is kubectl get pod. So it is going to display all the pods. So you can see here are all the pods related to the Prometheus. Okay, so there is a pod for Alert Manager, Prometheus, Grafana. Yeah, this is the one for Grafana, and rest everything is for Prometheus for each of the Prometheus components, right? So, I don't know for people, if you're not aware, what is Prometheus? Prometheus is a monitoring tool which is typically used to monitor the applications, and especially the applications running on the Kubernetes clusters, or the applications that are running as containers, right? So Prometheus is the monitoring tool. So this Prometheus is gaining a lot of importance today, mainly because to monitor the applications which are running as containers. Okay. And Grafana is basically a graphical tool which can connect to the any monitoring tools. It can collect the data and provide the data in the form of graphs. Okay. So let us continue here. So let us try the remaining commands. So kubectl get pod. Okay, I think that is a command we got the output before. Now kubectl get all. Okay, so with this command, we are going to get information about all the components, right? So starting with the name, and you can see that it's now here it is talking about the services. What are all the various services that got created as part of this package installation? Then what is a daemon set? All the Kubernetes components, whatever is created as part of this application, everything you can see it here. Here it is talking, it's showing the deployments, whatever deployments that were created for Prometheus and Grafana. Similarly, replica set. Here you can see the replica set, whatever was created. And below you can see the stateful set, whatever was created, right? So this command will give you all the components that were created as part of this application installation, that is Prometheus and Grafana. Now, if I want to get some specific information about the config maps, I can give this command kubectl get config map. So it is showing me all the config maps that it has downloaded in regard to the Prometheus and Grafana. Now I will say kubectl get secrets. So this will show you all the secret files. You know, the files containing some credential information for the authentication. So that is all available in this kubectl get secrets. Okay, then kubectl get crd. This command is going to return all the custom resource definitions that were created part of this package. Again, if you want to see the stateful sets, I can give the command kubectl get stateful set. So we have two stateful sets here. Okay, now what we'll do is we will try to get the config.yaml for the Prometheus package, and then we will try to access that application via the service. So now is that the package is installed. Prometheus and Grafana both are installed. So how do we access them? That's the step we are going to see now. So kubectl get config maps. So this is the config map name, and I'm going to export that to a config.yaml file. Okay. Now if I vi this file config.yaml, you can see this how this config.yaml looks like. So these are the default configurations, but if at all we want to change anything on this YAML file, we can go ahead and do that. By default, it is including a runbook URL. Okay, so all default parameters are available on this config.yaml file. Okay, so now how do we access this application? So we will follow these steps. first we will try to get the service. What is the service name it has deployed for Prometheus? This is a service name. Or I will maybe give this command kubectl service grep -i Prometheus. Let's see what this returns. Okay, so you can see it is listing some service names for the Prometheus software. So I'm going to take this one, Prometheus cube Prometheus -Prometheus. Okay, so let us try to get the details for this service. Okay, so let me give the command kubectl. This is a service, right? kubectl get service. This is my service name. That is Prometheus -cube Prometheus -o void. So I want to know how the service is currently exposed. So you can see that there is a cluster IP 10.100.194.170, and internally at the cluster level, it is running at these two ports 9090 and 8080. But now I want to access this Prometheus application from the outside world. How do I do that? So for that, I need to edit this Prometheus.yaml file. And in that YAML file, I need to change the service type to node port. So that is what I'm going to do. So let me execute this command. So kubectl get service, the service name, minus the output of that service, I am redirecting to a YAML file named Prometheus.yaml. Okay. Fine. Now let me open this file, Prometheus.yaml. And let me go to the end of the file. You can see here type is cluster IP, right? Type is cluster IP. I'm going to change it to node port. The type, I'm going to change it to node port. So if you have not watched my video on how to expose an application via node port, there is a video I have put it in my channel. You can just go ahead and watch that. I think that is available on the video, how to spin up Kubernetes using kops, I guess. So you can just take a look at that video. Now I have changed it to node port. Now we want to have these changes into effect. So I'm going to execute this command, kubectl apply -f Prometheus.yaml file, right? What it means is take the new configurations, whatever has been updated on the YAML file. Okay, so now it has updated the service configuration. Now I'm going to execute the same command again, kubectl get service -o void. Now you can see here, team, basically it has used the node port 32360. Can you see it? And there is another port that is for a different component of Prometheus. But ideally, this is a node port 32360 and 30967. Okay. And if we open this port 32360 for our Kubernetes nodes, we should be able to access the Prometheus application on this port. So can we try that? So let me go to my instance. These are my two nodes in Kubernetes. So let me go to the security group of my first node. Okay, let me click this. And I go to the inbound rule. So what I'm going to do is I'm going to add a new rule here saying custom TCP. And what is the port number here? 32360, right? So 32360 from anywhere. Okay, then I will add one more rule for the second port also. which is 30967, 30967, anywhere IPv4. Save the rules. So once we do this for one of the nodes, I think even the second node also will be taking the same configuration. We can just go and double check the security group of the second node on the cluster. I go to edit inbound rules. Yeah, you can see that these two ports are added already, 32360 and 30967. I think 967 is not added, looks like. Let me add that. Oh yeah, it is there. Okay, it is on the top. Fine, I think it is added already, so we should be good. Now, how do we access the Prometheus application? Via the node port. So let me grab the public IP address of the first node and I'll put it in the browser. What is the port number? What is the port number where Prometheus is exposed via the service to the outside world? It is 32360, right? So I will say 32360. That is the reason we opened this port in the security group. Enter. Now you can see it is opening the Prometheus page, right? So we are in the Prometheus console. I think this is the home page and we have, multiple other menus. So these are all the screens with the list of alerts, what we can configure for monitoring our Kubernetes cluster. Okay, then we have the graph option here. Then there is a status, runtime and build information. Okay. So you have the alert managers endpoint also. So basically, yeah, this is how we are able to access the Prometheus cluster, which was installed by the Helm chart, right? And we are doing it via the node port. So here, this 32360, that is nothing but the node port. And we can access it via the other node also. So we have the second node, right? So when I grab the IP address of the second node, let me put that in the browser, what is the port? It is 32360, right? The same port. So 32360. See here, from the second node also, we are able to access the Prometheus application through the node port 32360. Okay, so now we are done with Prometheus. Let us do the same thing for Grafana. Because this package, this Helm chart is a combination of both Prometheus and Grafana, right? So we will try to expose the Grafana application as well, and we will try to access the Grafana too. Okay, now we will do the same step. I'm going to populate the service information of Grafana to the grafana.yaml file. Okay, now let me open the grafana.yaml and I'm going to do the same thing, the type here. So instead of cluster IP, I'm going to change it to node port. Node port, okay. That's it, the same command to, make the changes to effect. That is kubectl apply -f grafana.yaml. Right, I think now the changes are taken into effect. Now we will check the service information about the Prometheus-Grafana service. So what is the node port that it has exposed? Now you can see here, this is the cluster IP that it is showing, and the node port is 32106. Okay, internally at the cluster level, it is running the application on port 80, but for the outside world, we need to access Grafana at 32106. Okay, so now what we will do, in the security group of the Kubernetes nodes, we will open this port and then we will try to access Grafana. So I'll go back to my instance dashboard and I'll go to my first node. Let me edit the security group. Edit inbound rules. Let me add a rule, custom TCP. And what is the port number? The port number is 32106. So 32106 from anywhere. Fine. So doing it on one node, it gets replicated on the other node also. So now if I want to access Grafana instead of Prometheus, so what I will do here in the browser, instead of this port 32360, because Prometheus is accessible via 32360 and now Grafana is accessible via 32106. So let me say 32106. Enter. You can see here now it is loading the Grafana's home page, right? The same thing I will do it for the other node also. So instead of 32360, so I'm going to say 32106. You can see we can access Grafana from both the Kubernetes nodes via the node port. Okay. So now let us try to log into this application, Grafana. There is a default username and password. Username is admin. Let me password. Login. Now I'm inside the Grafana tool, the home page. So basically, you can integrate Grafana with any other monitoring tools like Prometheus as a data source, and you can collect the information from monitoring tools and put them in the form of graphs, right? So as I told you, Prometheus is a monitoring tool more for applications running on the containers, and Grafana is a graphing tool. Okay, and we saw today how do we install these packages Prometheus and Grafana using the Helm chart. So I hope all these instructions are clear, team. So I will just quickly recap what we did. So basically, we just the first prerequisite is you need to have a EKS cluster spinned up. Okay, any Kubernetes cluster that is spinned up, but you can watch my EKS video and get a cluster spinned up in EKS. And after that, from the EKS bootstrap system, you need to do all these steps, right? That I showed you. First, you need to download and install Helm. Then you need to add the repo for that Prometheus and Grafana, which is containing that Helm charts. Using the command Helm add repo. Then you need to update the repository to get all the up-to-date changes. Then you need to follow those steps to install Prometheus and Grafana using those Helm charts. Okay, by calling the respective Helm chart name. Then post that, we need to validate the applications. So that's what we did. I created a node port. By default, it was cluster IP. I changed it to node port, identified what is the node port, and opened that node port in the security group, and we were able to access both Prometheus and Grafana using those node ports in the browser. Right? Now the last step, we will see how to uninstall the Helm chart for Prometheus. So that's a very straightforward step. I'll just go back to my console here, easy to console. And for uninstall, it's very simple. The command is /hem uninstall release name. So in our case, the release name is Prometheus. So once you uninstall this release, it is going to uninstall all the dependent components like your pods, deployments, the CRDs, that is the custom resource definitions. All the components will be uninstalled when you just uninstall the release. Okay, so let me go ahead and give this command to uninstall the release, whatever was installed using the Helm charts. You can see here. Now the release Prometheus has been uninstalled. Now if you try any command like kubectl get pod, that time it was showing good number of pods, right, for Prometheus and Grafana. Now you are seeing that no resource found in the default namespace because everything got deleted. Similarly, if I say kubectl get config map, yeah, maybe it is showing the default config map for the Kubernetes cluster, but nothing for Prometheus and Grafana because we uninstalled the release itself. So it has uninstalled all the dependent components of that release. Okay. So team, this is how we use the Helm charts in order to install any applications on the Kubernetes cluster. So the one that we tried today is installation of Prometheus and Grafana. So like this, you will have the Helm charts available for any application, whatever you want to install in the Kubernetes cluster. Okay. So I hope this video was helpful. So you can also just try these instructions, and if you have any doubts, any questions, you can feel free to put it in the comment section. I will take a look and I will respond to your queries. Okay. And if you are not really subscribed to my channel, please subscribe to my channel. And if you like this content, please hit the like button, and also please hit the notification button if you want to, get a notification whenever I post any new videos. So yeah, maybe I would like to end here, team. Thank you for patiently listening to my video, and I will catch you all in my next video. Thank you all so much.